Welcome to the WuBlockchain Podcast. For the latest blockchain and crypto insights, subscribe to WuBlockchain on YouTube and follow us on Twitter. Stay informed and join the conversation. Today we are excited joined by Dr. Rand Hindi, CEO of Zama. Welcome. Could you briefly introduce yourself and the journey that led you to build Zama?
Hi everyone, my name is Rand. I'm the CEO at Zama. I've been a developer since I was 10 years old, built my first company as a teenager in the 90s, then did a PhD in artificial intelligence when I was 21, over 20 years ago. I then built one of the first AI companies in Europe that was then acquired by Sonos in 2019. And since 2020, I've been building Zama with my co-founder Pascal Payet, who's one of the inventors of FHE, homomorphic encryption. I've also been in crypto since 2013, so I've seen 4 cycles so far. And I'm an investor in over 100 companies, from biotech to AI to crypto.
Was there a fundamental moment when you realized privacy would become the defining constraint for AI and blockchains?
Well, if I think about how I got interested in privacy, my first company that I built as a teenager was a social media network. And at the time, I remember seeing all the data that was coming into the servers and thinking that this wasn't right. That just because I was the founder of this company, it doesn't mean that I should be able to see all of this data. When I did my PhD, I specifically worked on AI applied to genetics. And so here again, manipulating medical data, DNA, made me also think that clearly we needed privacy for AI if AI was going to be something big. And finally, once I started working on blockchain, I've always found it incredibly weird that in the real world, you would never show your bank account to your neighbor, but somehow on blockchain, we've been told that this was normal. It shouldn't be normal. So I think privacy for me is not something that is specifically about AI, about blockchain. I actually think it's something that we need in every digital product that we end up using.
For those new to the topic, what makes Fully Homomorphic Encryption, FHE, fundamentally different from ZK and MPC solutions?
When you think about confidentiality, specifically in the context of blockchain, so let's talk about blockchain. If you want to enable confidential transfers, confidential stablecoins, confidential DeFi on blockchains, there are 4 technologies that exist today that enables you to do that. FHE, Fully Homomorphic Encryption, MPC, ZK, and keys. FHE is the only technology today that is secure, composable, and verifiable. So FHE is secure even against quantum computers. So the data you're encrypting and putting on chain today cannot be broken even by future quantum computers. That's really important because, as you know, quantum computers are happening and are coming very soon. If you look at other technologies, for example, Ts have been completely broken. Some research papers came out a few weeks ago that showed that Intel wrongly implemented Ts, and they were able to break every single blockchain that relied on T for privacy, every single one of them, because Intel messed up the implementation. Intel even came out and basically said that they don't care because they consider that decentralized protocols like blockchain is out of scope for the security of Ts, and therefore it's not something people should be using. Multi-Party Computation, FHE, great technology, great for key management, and we use it as part of the Zama protocol to handle decryption of balances, for example. But if you want to use it for computation, it's very hard to scale, and it's very hard to make it verifiable. FHE is publicly verifiable. Anybody could verify the computation was done correctly, just like any blockchain today. And you can scale by just using better hardware. So the more hardware you're using, the faster it gets. It's really that simple. And finally, ZK. I mean, I love Zcash, right? I've been a long time holder of Zcash. The only problem with ZK is that you don't have composability. So if you take something like a ZK token, you can shield token and you can transfer that to someone else confidentially, but it's very difficult to then take this shielded ZK token and then stake it to earn yield or swap it for something. So you don't have composability like you do with traditional tokens. FHE is completely composable. So you can stake your FHE tokens, you can swap your FHE tokens, you can lend your FHE tokens. Everything you can do with regular tokens on a public blockchain today, you can now do confidentially with Zama on the same blockchain where you're already having those assets today.
So how do you see these three paradigms, ZK, MPC, and FHE, coexisting in modular cryptography stakes?
I can tell you how we use all three. So in the Zama protocol, and maybe let me recap a little bit. So the Zama protocol is not a new L1 or L2. It's a layer of encryption on top of existing L1s and L2s, like Ethereum, like Solana, like Base, that enables you to have confidential tokens, confidential DeFi, without having to bridge to a different chain. So think of it like HTTPS, but for blockchain transactions. To make that happen, we're using FHE, but also some MPC and some ZK. So FHE is the main technology we're using in the Zama protocol. We use it for computing the encrypted state on chain. So when you make a transfer, your balance is encrypted, the amount is encrypted, but you still need to, send the balance to someone, update the balance of someone else. So this is what we use FHE for, all of the computation on the encrypted private state on chain. However, at some point, you want to be able to decrypt something. For example, the user should be able to see their own token balances. And so to do that securely, we basically use MPC to distribute and split and decentralize the decryption key amongst a bunch of different operators who have to agree to decrypt something for the user. So that's a way where you basically avoid having one decryption key. You can basically have decentralization for the decryption key itself. And finally, ZK is really important if you want scalability. So I think ZK as a scaling technology is fantastic. And so what we're currently working on is ZK FHE so that you can have something like a ZK rollup with FHE encrypted states inside of it.
Zama describes its technology as a privacy layer for blockchains. How does this layer integrate with existing EVM chains in practice?
So the nice thing about Zama is that it doesn't change anything to the way that you build or use a blockchain today. For example, if you're a developer and you want to build a confidential application on Ethereum using Zama, you write your smart contract in Solidity. You decide what's encrypted in your contract, what's not encrypted, who can decrypt which part of your contract, and then you deploy it to Ethereum. And as a user, you can use any wallet that exists today, and you can make a transaction to this confidential application on Ethereum. So if we do our job right at Zama, users don't even realize that we exist because we're not changing the way they use blockchains today.
Are you designing this to be the default privacy layer for multiple layer 2 ecosystems?
Yeah, totally. Everything is designed to be multi-chain by default. So we're not trying to be a new L1 or L2. We don't compete with L1s and L2s. We really come on top to add confidentiality to those public blockchains like Ethereum, like Solana, like Base, like Tron, like BNB, or anything else you might want to use. So if anything, to be honest, we're quite complementary. And for us, it doesn't really matter which chain you want to use or where you want to hold your assets. We want to enable you to have confidentiality wherever you are today.
What changes for developers when building encrypted smart contracts using Zama's FHE-EVM?
Frankly, almost nothing. It's just Solidity code that you deploy on Ethereum. And we provide a library that allows you to specify what's encrypted in your contract and who's allowed to decrypt what's in your contract. So for example, if you want to create a confidential stablecoin, you just write a Solidity smart contract in which the balances are encrypted integers. And then in your contract code, you also specify the rules for who can decrypt the balances. For example, the user should be able to decrypt their own balance, obviously. But let's say you wanted to build a compliant confidential stablecoin. You could actually build compliance features into your smart contract directly. For example, giving an auditor the right to audit specific transactions in your stablecoin for compliance or anti-money laundering purposes. Again, the Zama protocol doesn't force you to do one thing one specific way. We're giving developers tools so that they can build any confidential application they want with any level of privacy and compliance that they need.
FHE is often perceived as slow and expensive. What breakthroughs has Zama achieved to make it viable for on-chain computation?
To be honest, I think that was true before Zama existed. When we started a company, FHE was extremely slow. It would take maybe 10 minutes to make a confidential token transfer. Today, we're nearly 1,000 times faster than when we started a company 5 years ago. It really helps, by the way, that my co-founder is one of the inventors of FHE, that we have 37 PhD in the team. So we're today the largest research team in the space. So today, FHE is faster than Ethereum. So we can do 100% of Ethereum encrypted with FHE. But we're also now moving to GPUs that will give us 500 to 1,000 TPS per chain that we support. So 1,000 TPS on Solana, 1,000 TPS on Base, 1,000 TPS on Tron. And we're working finally on building our own hardware, so an ASIC specifically to accelerate FHE, which will enable us to get to 100,000 transactions per second on a single server, consuming less energy than a GPU server. So try to imagine one box in a data center is going to be enough to run global payments on-chain encrypted with FHE. So FHE now is no longer a math problem. We've solved the math. It's purely a compute problem. The more compute you throw at the FHE, the faster it gets, and the bigger the addressable market for this technology. It's that simple.
So what remains the biggest technical bottleneck now?
Build better hardware. That's basically it. That's it. It's just better hardware, faster hardware. So at the end of the day, building hardware, like the complexity of a FHE ASIC is roughly the same as like a Bitcoin mining ASIC, if you want to have a comparison. So, we're talking about $30 to $50 million investment. It's a lot of money, but it's not that much if you think about the scale of just what this enables, right? Global payments encrypted on chain. So that's it. For us today, it's purely a time and money problem. It's not so much of a science problem anymore.
From a scalability perspective, how far are we from FHE power applications that can serve millions of users?
Oh, I think we can do Ethereum today. Ethereum has 100 million users, so we can already do that now. I think if you want something like perpetual trading in FHE, we're going to need better hardware for sure because of the speed and number of transactions. And if you want something like confidential LLMs, confidential AI, we're definitely going to need ASICs. So I think, again, we can already address use cases with millions of people if those use cases don't require, 5,000 GPUs to run them, or if those use cases don't need, 5,000 transactions per second yet. But even those use cases, within the next 4 years, we're going to be able to address them as well.
What is the path toward real-time encrypted computation?
Better hardware. The answer is always going to be better hardware because that's basically the last thing missing today. FHE is secure. Even a quantum computer cannot break it. And we can run any kind of computation. You can do DeFi, you can do stable coins, you can do trading, you can do AI. We just have to get it faster. That's it.
One of the industry's challenges is balancing privacy with auditability. How does Zama ensure private computation does not undermine security or regulatory transparency?
I want to make something clear. Zama is for legitimate use cases. Everything we're doing to enable banks, financial institutions, companies, startups to build confidential applications. So we're building the protocol from the ground up to enable compliance at the application level. So the Zama protocol itself doesn't encrypt anything, right? We give tools for developers to build confidential tokens and confidential applications. So it's up to each developer and token issuer to decide what's encrypted and who is allowed to access the encrypted data in their contract. So let me give you an example. If you're a stablecoin issuer, right, and you want to enable confidential transfers, the balances are going to be encrypted, the amounts are going to be encrypted. You want the user to be able to see their own balance, of course, but you can also include in your smart contract, in Solidity, a way for you as the token issuer to see all the transactions of your own users. And then if you do that, you can comply off-chain, just like banks would do today, with anti-money laundering and other regulations. And if you think about it, that's how finance works today. You know, if you have a bank account, you see your bank account, your bank sees your bank account, but your neighbor doesn't. And we're trying to enable the same kind of model on public blockchains.
Does encrypted computation affect MEV ordering or fairness on layer 1 or layer 2 networks?
It changes nothing to the security of the blockchain itself, because we sit on top of L1s and L2s. We don't replace anything. We don't replace the sequencing. We don't replace the consensus. And the way that the system is architected, all of the rules for what's encrypted and who can decrypt it is on the L1 where the application is running. So think of the Zama protocol as a co-processor for public blockchains that augments them with its confidentiality capability, but we don't change anything to the blockchain itself. In fact, blockchains don't even have to integrate us. We just have to deploy the Zama contracts on those chains, and it will work. It will be available for any developers and users there.
Which crypto native use cases do you expect to adopt FHE first? DeFi, identity, gaming, AI agents, or something else?
I think, you know, there are multiple things that we see. So we talk to maybe 1,000 companies about what they want to use this for. One very big use case is payments. If you want to use stablecoins for payments, you obviously want confidentiality, right? If I came to you and I said, show me your bank account, you probably wouldn't feel very comfortable doing that. And so we want to enable the same kind of thing on public chains, right? We want you to be able to use this as a bank account without having to disclose to your neighbor how much money you're making or spending. So I'll give you an example of an app that is currently being built, which I think is great. So it's a company called Raycash. They're building a complete on-chain bank that cannot lose your money because all of your assets are using confidential stablecoins on-chain. So even if this company, Raycash, goes bankrupt, you can always just send your money to a different wallet and then you're fine. So it's like a bank that cannot rug you, basically. But because they use Zama, your account, your money, is actually encrypted on chain. So people don't know how much money you have in your bank account. But you can still stake it to earn yield on your bank account. You can still swap it. You also have like a debit card to spend it. You even have like a way to make wires. So you have all of the features of something like Revolut, for example, but completely on chain and self-custodial. I think that use case alone, think about all the countries where people lost money because their bank went bankrupt or because their government failed. You know, I'm from Lebanon originally. Our central bank a few years ago, one morning, they just decided they're going to take all the dollars in people's bank accounts. That's it. People woke up, no more money. It was gone. You know, this cannot happen if you're using blockchain, if you're using Zama for confidentiality. I'll give you another great example. The way that we are going to be distributing the Zama tokens is actually as confidential Zama tokens. So it means that everybody's going to get their tokens, but nobody's going to be able to know how much the other guy actually received. And again, that's important because you don't want this data to be public if you want to avoid people being jealous, for example. So I think in general, if you want to distribute tokens, equity to people, you want confidentiality for that. And finally, maybe another use case, which I think is really super interesting, it's everything related to trading in general. So if you are a trader today, let's imagine you're a foundation or you're a big investor and you're holding a lot of tokens. Every time you're going to move those tokens or trade them, everybody's going to freak out on social media. Oh my God, XYZ investor just sold a bunch of tokens. It must be going to zero. This is not normal, right? Like nobody wants that, right? This is bad for the market, for everyone. if you can swap token confidentially, if you can trade tokens confidentially, if you can deposit tokens confidentially to exchanges, all of that goes away. And so I think for me, it's very obvious that the question is not going to be what are the use cases that Zama enables. It's rather, what are the use cases that will not be using Zama in the future? I can barely think of anything.
Zama has an upcoming auction. From your perspective, what makes encrypted auctions an exciting use case for Zama's technology?
I love auctions. One of the most successful IPO in history was Google's IPO, right? In 2004, 2005, I don't remember exactly. So when Google IPO'd, they did what's called a sealed bid Dutch auction. So people could participate by bidding to buy Google stock in a way that other people wouldn't know how much you're bidding. So basically the bids were confidential. This was great because it meant that there was a lot better distribution. It was a more fair mechanism for retail participants. And also importantly for price discovery, it means that the price at which Google started trading on NASDAQ was actually the price people believed this was worth. And so when I thought about it, I was like, well, we should do the same for tokens, right? Because one of the hardest things for tokens is how to distribute tokens in a fair way, and how do you figure out what's the correct price? Well, to be honest, the correct price is what people say the correct price is. And the best way for them to say what the correct price is without bias is to participate in an auction with sealed bids. So we actually built a sealed bid Dutch auction on chain using Zama itself, and we're going to use that to auction Zama tokens to people. So we're using Zama to sell Zama tokens to anybody who wants to become a user or who wants to become a developer or a validator in our protocol. And we're using the exact same mechanism as Google did back in those days for listing their stock.
So what parts of the auction need to stay encrypted? Fixed identities, clearing, price logic.
Correct. So the whole bid is encrypted. So when you want to participate in the Zama auction, the first thing you need to do is you need to shield stablecoins. So we accept USDT, USDC, the usual stablecoins. So you convert those stablecoins to encrypted stablecoins, and now you can basically use those stablecoins to participate in the auction by bidding at any price you want. So you can bid as many times as you want. The price at which you're bidding is public, but the amount that you're bidding is private. So people don't know if you're bidding $1 or $100 at that price. At the end of the auction, we go from the highest price to the lowest price. And the lowest price at which someone got filled, their bid, is the price everybody ends up paying. So if you paid more, you get a refund for the extra and the token you wanted. If you paid less, you just get a refund and no token. And that's the concept of a sealed bid Dutch auction. And we're going to do that on Ethereum mainnet using Zama itself to run the process.
What types of decentralized application become possible only with FHE and cannot be done with ZK?
Any application where you need composability. So for example, if you want a confidential token that you can transfer but also stake and swap, you need FHE. If you want a confidential identity that you want to be able to use in a smart contract to get access to a DeFi protocol, the best way to do that is FHE. If you want to trade without disclosing liquidation price, the best way to do that is FHE.
How are you building towards SDKs or infrastructure to make FHE development easier?
Absolutely. I think everything we do, without exception, we're building it in a way that integrates natively with whatever developers are already using as tools. So for example, if you're building an application for Ethereum or Base, you will just write Solidity code using the Zama SDK in your Solidity library. If you're building a contract for Solana, you'll just use the Zama SVM library to write your Rust code or contract. We really try to make sure that developers don't have to learn a new language or like a new concept, and they can just use whatever they like using to build their application. Because let's be honest, as a developer, and I've been a developer my whole life, what you want to focus on is building things. right? You don't want to spend your day trying to figure out how a new language works or something like that. You just want to build, you want to ship, you want to build, you want to ship. And that's what Zama has been focusing on enabling for developers in blockchain.
You were early in AI before Zama. How do you see FHE enabling private AI both on-chain and off-chain?
Well, I think it's very obvious that we're never going to have AI on-chain if everybody can see your prompts. It's just not going to happen. So I think you need FHE or something else to enable confidential AI on public infrastructure. So I think for a deep-in, confidentiality is necessary for AI. But even without going into running the AI itself, imagine, for example, you want to enable payments between agents. You still want those payments to be confidential. So I think something like the X402 protocol for agent payments, you need to encrypt that with FHE as well if you want that to be widely adopted. So don't think of FHE as something that you're using just in the application. Think of FHE as a confidentiality layer that you're just putting everywhere by default. Just like HTTPS. When you connect to a website, the communication is encrypted. The data is encrypted. You don't think about it because everybody does it now. When I send you a message on Signal or Telegram or WhatsApp, the message is encrypted. We don't think about it because it's by default. We want to do the same thing for blockchain. Privacy should be by default. It should not be something people have to worry about.
Could FHE solve the trust problem with AI agents making financial decisions?
I think if you want to trust an AI model, you have to give it more personal data. And then if you give it more personal data, you want it to be confidential. I think it's confidentiality is needed if you want a really personalized AI experience. It's not going to happen without it.
As privacy regulations tighten globally, how will FHE intersect with compliance frameworks?
So we don't decide what compliance means. We give a tool for developers and token issuers to build compliance into their own application. So it's up to them to decide how to be compliant, who's allowed to access the data under contracts. We as a protocol are just providing the infrastructure to make that work.
Oh, so can you share with us about your team and how this team operates as the whole system?
So today we have about 100 people working at Zama, 37 PhDs. So we're the largest research team in cryptography and FHE for sure. We have incredible people. My co-founder Pascal Payet is the inventor of the Payet FHE scheme. Nigel Smart, super famous professor. Marc Joie, great people all around. And we're fortunate also to have raised over $150 million in funding. Our last equity valuation was 1.2 billion. And we raised money from Multicoin, Pantera, Blockchain, Protocol Labs, which means that Zama today is probably one of the best capitalized companies with the most resources, talent, and runway to make this vision of confidential blockchain happen.
Zama also raised new money this year. Can you share your partnership with your investors?
One thing that I love about Zama is that we're fortunate to have incredible investors that have been backing us from the early days. When we started a company 5 years ago, I told them, I'm like, look, this is new technology. It's going to take us some time to make it work, probably years before we can even start thinking about building a business. And they understood that. They funded the company to build something that was extremely complicated, very cutting edge, because they understood that if we could make it work, it would be absolutely a game changer for blockchain, for AI, for all of those applications. And so today that's happening. We build the Zama protocol, it works, it's going to scale extremely fast. And so I think, it would not have been possible without the support of those amazing investors. And, and having investors who have been through multiple blockchain cycles before, who have seen it firsthand, like that's invaluable advice and help that we can get.
Over the next 3 to 5 years, how do you see blockchain privacy evolving? Will FHE become a fundamental layer across networks? And where do you see Zama playing in this transformation?
Well, I mean, I think for me, there is no doubt. If you look at the internet and HTTPS as a good example, in 10 years, between 2013 and 2023, the internet went from having no encryption at all to over 95% of websites now supporting HTTPS encryption. If you look at messaging apps, text messages, SMS, there was never any encryption, but the day Telegram came up with encryption and WhatsApp integrated it, overnight, 5 billion people had a way to communicate encrypted in their messaging apps. And today it would be impossible to imagine sending a message to someone if it's not encrypted. And I think the same is going to happen to blockchain. Privacy is one of those things where it doesn't work until it does, but when it does, it becomes extremely fastly adopted. It goes from being inexistent to being the default mode in just a few years. And that, I think, is what's going to happen to blockchain. And I'm really, really, really doing everything I can to make sure people are using Zama because it is the best solution to make that happen.
And for the Zama teams, how do you keep a research-heavy team aligned with execution timelines and ecosystem demands?
That's hard. That's hard because sometimes research takes years. I think, you have to differentiate between short-term research and long-term research projects. So sometimes, you have ideas that you can probably test very quickly. Sometimes you want to work on very long-term ideas that's going to take years, but if it works, the impact is huge. So we do both at Zama. We have some projects which are long-term projects, some of them which are short-term projects. But importantly, everybody in the company understands that we're a company and that, we now have a protocol and that there are people using the protocol and that it's our job to try and work and improve the quality of everything that people are using coming from Zama.
Many technical founders struggle scaling from a research lab to a real company. What were the hardest organizational challenges Zama faced?
I think the hardest thing for us, to be honest, is we started a company in 2020 during COVID. And definitely doing the research when you're not in an office together is much harder. There's something about being in front of a whiteboard, which is really, really helpful for, fundamental research. So I think putting in place good frameworks and operational models to enable decentralized remote research collaboration, I think that was a hard problem for sure.
Are there any upcoming events from Zama that the community should be aware of in the next few months?
Well, the two most important events right now is we're launching mainnet before the end of the year. And then in January, we're going to be doing the auction to sell the Zama tokens. And basically anybody who wants to use Zama tokens, anybody who wants to be an operator or validator or help secure the protocol, any developer who needs tokens, they're going to be able to get some. And I want to really emphasize that. We are doing an auction to sell tokens for an existing protocol that's already built, that's already in mainnet. This is not for a future project. This is a sale for people who want to use the token in the Zama protocol. And I don't think very many people in crypto did that before, doing a public auction and sale for something that already exists, using our own technology to run the sale as well, by the way, I think this is something that's very new.
Zama has made rapid progress from FHE EVM to encrypted applications. What's the next major step in turning FHE into a mainstream blockchain primitive?
Next step is 1,000 TPS on GPU, then 10,000 TPS on GPU, then 100,000 TPS on ASIC. That's it. The goal now for Zama is very simple. Make it faster, make it cheaper, make it more widely available in more blockchains. That's it.
Thank you for joining us today and sharing your insights.
Thank you.